expanding a binomial, so kind of similar. Again, I need to use the third row of Pascal's triangle, so 1, 3, 3, 1. So I'm going to say, all right, this is going to equal 1x to the third plus 3x squared plus 3x plus x to the 0 is just 1. All right, there we go. That looks pretty good. Notice what's happening is my coefficients are following Pascal's triangle and my exponents are decreasing by 1 until they go away. Now, if I have a similar example, but I have a subtraction sign, so again, see the subtraction sign? It's the similar process, but we subtract or we alternate our signs. So here I use subtraction and here was just positive addition. So we have to alternate our example. Now maybe we have x minus 1, but this time we're going to raise it to the fourth power. So I got to use a different set of numbers. 1, 4, 6, 4, 1. So x to the fourth minus 4x to the third plus 6x squared minus 4x plus 1. Again, notice the alternating. Expanding a binomial expression, if you have some coefficients, it's going to be slightly different. So let's say that we have 2x minus 3 to the fourth, and we want to write this out. So again, I'm going to use the Pascal's triangle, the fourth, 1, 4, 6, 4, 1. And so this time I'm going to say, I'm going to kind of separate. I'm going to have one term be 2x, and the other term is going to be 3. So as we go through this, there's not there. So my coefficient is a 1, and then I have 2x to the fourth power, and because it's subtraction, I'm going to alternate, minus 4 times 2x to the third, and then this time I have 3 plus 6 2x squared times 3 to the second power. Again, you could put a 1 here. Doesn't change it. It's the same thing. And now we're going to subtract. I know we're kind of running out of room. These do take up a lot of room. Minus 4 times 2x, again to the first, 3 to the third, and then plus 1. 2x to the 0 power cancels out. So we are just left with 3 to the fourth. So after you go through, and again, that's going to be a lot of simplifying. 2 squared is 16x to the fourth minus 96x to the third plus 216 x to the x squared minus 216x plus 81. So that's what this polynomial would be, or this expression would be expanded all the way out. Let's do one more of those. Those are good. X minus 2y to the fourth. So again, fourth row. Again, I'm going to say I have a term of x and I have a negative 2. Why? Because this is minus, I need to subtract. So 1 x to the fourth, we can just write it 2y to the 0 plus 4 x to the third, 2y to the first plus 6 x squared, 2y squared. Oh, I forgot to alternate my signs. So this should be minus plus, and then this is going to be minus 4x times 2y to the third plus 4, and then 2y to the fourth. No, not 4. This is just a 1. So easy to make a mistake when you're expanding these out. So after simplifying all of this, you should get x to the fourth minus 8x to the third y plus 24x squared y squared minus 32xy to the third plus 16y. 16y to the fourth. Expanding a binomial, write the expansion for the expression. X squared plus 4 to the third. So Pascal's third row of 1, 3, 3, 1. You'll start to kind of memorize them once you get the hang of it. 1, my first term is x squared. So x squared, and then that's to the third power. Remember your exponent rules, plus 3, x squared squared, 4 to the first, plus 3, x squared to the first, 4 squared, plus 1, and then it's just going to be 4 to the third power. So after doing all that, you get x to the sixth plus 12x to the fourth plus 48x squared plus 64. All right, last example of this unit. Find the sixth term of a plus 2b to the eighth power. So, and then we'll do that first and then we'll do the last part. So we know that in this case, n is 8 because it's to the eighth power. And we know that r equals 5. My row is 5. Because the formula is for the r plus 1. And in this case, r equals, or we're trying to find the sixth term. Sixth gives you r plus 1, so that's why we're saying r equals 5. So if we were to write it out, how we've kind of looked at it, we have 8, choose 5, and then whatever my first term is, which in this case is a. Remember, my exponents always have to add up to 8, so I'm going to say this is 8 minus 5, and then my second term is 2b, and then that's going to be 5 because this was 3. So therefore, when we start to get down into it, we say, all right, I know that if I'm looking at this row, Pascal's triangle, I need to find the eighth row, and it's going to be the sixth one. So that's going to be 56. So my first term starts with 56 times a to the third times 2b to the fifth. So I'm going to multiply 56 times 2 to the fifth, and I still have a to the third and b to the fifth, which gives me 1,792, a to the third, b to the fifth. All right, there we go.